Proteins are vital components of all living organisms. They play a role in the immune system as antibodies that identify foreign invaders, function as enzymes that aid chemical processes, help cells in your body coordinate and communicate with one another, and many more functions. Proteins are commonly referred to as the building blocks of life due to the wide range of critical roles they play in the body throughout structure, function, and tissue organ regulation. All protein molecules are made up of a chain of smaller units called amino acids. There are 28 amino acids, which all have different chemical properties and makeup, causing them to behave and interact differently and perform different functions within a protein. Given the definition of proteins, the protein folding problem asks, can a computer algorithm be devised to accurately predict 3D protein structures from their amino acid sequences? According to an article by a senior in 2020, the amino acid sequence of a protein largely determines its structure and function. However, protein structures can be difficult to determine experimentally because a protein can theoretically fold an astronomical number of ways. Given the ability to accurately predict protein structures from their amino acid sequences, efforts to understand the building blocks of cells would be greatly accelerated. Enter AlphaFold, an artificial intelligence program that can predict 3D protein structures with remarkable accuracy, deriving predictions within a width of an atom from the experimental result. Given an amino acid sequence, the algorithm looks through similar amino acid sequences and structures in protein databanks to build an initial structure of the protein. Through this, the algorithm finds which amino acids are likely to be in contact with each other. After, the structure is put through an iterative process in which the structure is analyzed and decides at each step which other pieces are important. This results in the information of the structure being improved more and more at each iteration until the structure cannot be improved further. The final output of this is 3D coordinates of every atom in a protein structure. A 2020 DeepMind blog shares the importance of the software in the medical and environmental fields. As stated before, protein function is determined by its structure. Many diseases are the result of absent or malfunctioning proteins in a person's body, or presence of foreign proteins from invaders such as viruses. The better scientists understand a disease, the easier it is to develop effective drug treatments. Therefore, the ability to easily predict protein structure would assist in development of drugs to combat the many diseases that are a result of foreign or malfunctioning proteins. In fact, this technology was used to determine structures of proteins for the current COVID-19 virus. The same blog also reports that AlphaFold may lend itself to the discovery of enzymes that can degrade wastes, such as plastic. Scientists are also examining the possibility of using proteins to capture carbon dioxide from the atmosphere in hopes of mitigating global warming, and this software could prove advantageous in the discovery of a protein that can accomplish this.